Hello, welcome back to BLENDERSUSHI live noding. In this video, I'm gonna kind of just gonna chat and talk about um, randomness and noise, and kind of going through what I've been doing, researching about functions, and basically I've been reading this book called The Book of Shaders, and apparently this book is not yet finished and it's still on like ongoing stuff. And this book talks a lot about functions and especially to create shaders. And it's I've been through this shader programming stuff a few years ago, but then and I get to the part where OSL kind of make a little bit of sense but not too much. And because the problem is going from functions and going from numbers and then try to understand functions and then try to see how the functions can create and generate procedural image. It can get pretty complex. And a few years back I was pretty kind of maybe a little bit stuck um, because a lot of these functions generations get a little bit too complex in a way that really you just need that function, in order to generate this beautiful image. You either get like one function that already does everything for you, or you start from scratch. And starting from scratch and to get to the points where you have like a beautiful noise is kind of um, difficult in a way that because you're probably not a mathematicians or like a computer scientist, and this is their job, like to create functions that we can use as a computer artist. um, However, you probably eventually realize that you already have most of the functions anyway, like things like Voronoi or Perlin noise, or what else, Musgrave, or all these chaotic functions that can generate like chaotic numbers. You kind of have that. And because in when I'm doing live noding and using animation nodes or Sverchok, we kind of have some of those functions. Like the complexity is actually hidden inside the functions, and it's no longer, sometimes it's not like about thinking how to create those complex functions, but actually to mix the functions together and kind of making sense of how to separate the data and in a way that makes sense to you, and then to reuse that for your own purpose. And I was also have been watching this video by Daniel Shiffman. It's for processing, and then processing also you use Java or JavaScript code, especially for processing and to generate visual language. And it goes through a lot of interesting stuff like interactivity, and also to procedurally or generatively create like abstract art, or how you can use camera to kind of sample your environment, real life environment, and then turn it into data that you can kind of reuse the data for to generate another image. And this is one video. This is like really long video, almost like 3 hours, where Daniel Shiffman goes through a lot of things. If you try to watch this for 3 hours, it's kind of a lot to take. And he was talking about um, randomness and noise functions. So it's actually, these books of shader also talk about randomness and noise and about functions, all those kind of stuff. So how is that knowledge can transfer to things like animation nodes or Sverchok. Um, in this case, I think I will kind of like, I will use like just a couple of nodes inside Sverchok and then try to kind of clear up few things that you might not think of. Like, for example, let's start with let's just turn on create a Sverchok node and then let's jump into it. Actually, I don't know where to start really, but let's say you imagine you have like random vector. Okay, random vector. These nodes will generate bunch of points, right? You already know this. I did this few times now. So random vector, you specify how many numbers you want to create, and then what's the seed? Is the seed kind of randomized? It's gonna give you like random numbers of those random numbers. Let's say maybe you have like you ask this node to generate 5 create 5 random points with a seed of 15. You just plug it into the viewer draw and you get, of course, you get 5 points, and then by randomizing the seed number can be anything. It's just, it doesn't really matter. It's just if you have 2 of these guy, you know, you can have 2 lists of 5 numbers. That's pretty random, and by default they are kind of limited to the number between 0 and 1. So I think I will also use a viewer draw. I'm gonna save this as Sverchok controlling chaos. So chaos and control is, and I will gonna go through random functions and noise function as well, maybe. So I'm just gonna talk for a couple of minutes, I guess. So random vector. So by default, like I said, I'm gonna use a viewer tags. It's just gonna generate points, right? Points. Is points so useful for us? The points won't be so much use for us. Like even like these random numbers. Actually, random numbers is generating numbers between -1 and 1. So you can see it here, and then of course we already learned that we can just remap it using map range. So by using map range, you can remap all the numbers to the value that you want. But random vector itself has 3 different values. So in this case, we want to kind of separate the vector. So we can use vector out and vector in, and we can remap all those values. Okay, this is one for one of the values, this is for the second one, and this is for the third one, and then we can pipe it back as a vector. We can check the number now. By default, the map range is looking, the value goes in and it's looking at the numbers. By default, it's like from 0 to 1 and become from 0 to 10. Because random number is between -1 and 1, so you want to kind of change that. And now you will see that the number is now between 0 and 10 for each of the vector. Okay, I just accidentally hide the points, but now we get it back. So now it's between 0 and 10, but maybe you want it between -5 and 5. You can do that for each of the axes, -5 and 5. Or maybe you don't want any value on the z, you can just zero it out. So you have just now have like a flat random points, and you increase it and you get a flat, like a circular points within like a circle that's scattered randomly. So this is one of the things with numbers, you start with numbers and then you process the numbers through this using these nodes. You process the numbers and you're getting numbers that's more what you need. That's with random, for example, and points won't be much of use, but in Sverchok I found out that at one point we can actually use line. For example, if we use line and pipe in the edges, you can generate I think I accidentally turned that on. Okay, you can generate like more like a random lines. You don't have control on the step. Doesn't matter anymore because it's only looking at the points we generated using random vector, and then this doesn't matter anymore. This basically we have random points, and then we can control how the points get spread in the 3D space, and using this line node and just the edges data, we can connect the lines like that. There is also a specific nodes that you can use to kind of connect the points. There's a connection, UV connections. That's the one we need. So this is doing it more correctly, where we have a bunch of points, and then okay, these nodes will understand those points, and then it will connect it. And we can also generate like polygons that way if we turn on the polygons, but we want just edges, and you can do it in the U or in the V directions. That's it's not really making sense for lines, because line maybe is just one-dimensional. But if you are using things like grid or cylinder, then this U and V directions will start to make more sense. So let's switch to cylinder. Okay, this is from a dots, like from a points, and then we have a bunch of points, and then we connect it, it's become a line. It's like from one-dimensional it becomes two-dimensional, and then three-dimensional if we have like for things like cylinder is more like three-dimensional. That's gonna cut. I'm gonna cut that and create a cylinder. File save as. So cylinder by default, it of course generates a cylinder, and cylinder is made of. If you look at the components, you can see there's in 3D. As you understand it, you have like you have the vertices, you have edges, you have the vertices, which is all these points, and you have edges, all the edges that's connecting the points, and then you have the face, polygon face, which is this. In this case, the cylinder have the top and the bottom, and this node does that for you. It's kind of okay. This node has certain recipe or certain algorithm inside it that generates this cylinder. You can turn off the caps, so you don't have the caps. You just have all these polygons on the sides. That's fine. That's cool. And you have also other settings like that's controlling the radius top and radius bottom, and you have this controlling the number of vertices that generate the cylinder. you have the height, and you have the subdivisions. Okay, all those sort of stuff. But if you see, if you tweak this and then okay you want to make the height 0, and now you have suddenly you have like something that's more like a spider web. If you want to start from scratch and then to generate this spider web, you might think of maybe you start with lines, or maybe you start with circle, you know, like all these components to do this kind of design. That's the thing, you know, like sometimes you actually if you know the final result that you want, you don't need the exact functions to get that kind of look. You can kind of mix and match, kind of think of like a smart way to get to your final result. Yeah, so I'll just gonna continue with this. So with cylinder, okay, you have like things like spider web. Okay, that's cool. We no longer have a cylinder, it's more like spider web. And I saw one of the video by Nikita. Nikita is one of the Sverchok developer, and in one of his video he uses UV connections, and then just this node, cylinder and UV connection, he managed to break this cylinder into like a just like a circle or just lines. It's kind of really interesting because I'll just gonna show it to you. The secret is to separate the data here. Cylinder and grid, actually the plane, cylinder and plane, a line doesn't have separate, but cylinder have separate options just like plane. And this is actually interesting because you can use cylinder to actually generate circles of circles. Caps doesn't matter. Let me try. Okay, we don't want polygon, we just want edges. So now, okay, now we have something that's looking like circle, but it's not. That's because we didn't turn on the cycle U. So now, okay, now we have a bunch of circles, and we still have control over the radius top and radius bottom. And this in itself is almost like a in Sverchok, if you have like a circle with the same and then you have another bigger circle with the same number of points, you can kind of interpolate those two together, and you have this kind of pattern, like a not like a snail, it's like a circle in circles, and then those points can, with interpolations, I think you need the same number of points. But you might realize that you can randomize the points, so you can, it doesn't need to have the same numbers. For that, that's maybe for next time. But I'm just showing it to you that cylinder can be broken down back into its circles. And even here you can perhaps randomize subdivisions. I don't know, maybe subdivision you cannot. You can play around with the height, vertices. I don't know if you can have random vertices, maybe that's not gonna work. I can try random range, integer, and maybe start from 3 and then step 1 count 10, plug in there. That's probably not gonna work. You kind of, maybe you need to kind of break the data more. Sometimes Sverchok can still surprise me with all the possibility. Maybe I can plug it to the top and get certain kind of design. Maybe let's don't do that for now. But here we have circle, and then if I'm not wrong, you see here when we separate the data, now we have actually like 8 and 8 here, and with that you can use the matrix in and line. Oops, okay, Blender just crashes. I'll restart real quick. Always save often when working with Sverchok. Sometimes it's maybe it's surprise Blender. Let's wait a little bit. Okay, let's reopen where we left off. Okay, the good thing is I always save almost every second sometimes. Cool. Okay, we have this guy, and maybe we can use the matrix in, plug into this guy. We know that we have 8 different objects here, and we can use line, maybe line or random number. Okay, random vector. Plug in into the locations, and we have 8 counts. So the random, in this case, the random points is generating random points, and then that's gonna reposition all this cylinder that's been broken down into circles. Okay, that makes sense. If we bake it, it's just gonna be, you know, like this, like a bunch of polygon. Each one have slightly bigger scale for each one of them because it's based on the cylinder. Okay, that's fine. You can also rotate it and stuff. If you don't want it to be too if you don't want it to be random, you can actually use line. Line, as you know, it will create lines, but line is made up of points, and the lines can go in the x directions, on the z or the y, whatever. But it's made up of points, and we can use the points to place our broken down cylinders. Let's try doing that. So by default, line is going in x-axis. So if you, I think Sverchok has this vector x, y, z. No, in this case we can use vector out and vector in. And we plug in the line in there. So since we know by default line goes up in points number in the vector going in the x-axis, if we want it to go in the z-axis, for example, we can plug the x into the z, and then the z into the x, and then now we have the line that goes up. And we can control the spacing. In this case, really with the line, I just gonna zero out the steps, and we have this. So if we use the viewer text to see the numbers, so it's a 0, 0, 0, 0, all 0. It's kind of like a repeating a number. If we have a 0, 0, 0 and we want to repeat it, we can use list repeater and plug in the data. This level unwrap can be confusing, but the way to understand it is to compare one data with another data and it kind of trying to make sense of it. So the line generate points that Sverchok like to use with all other stuff. By default, if you have like a number 000 and you want, okay, I want to have 10. You look at the number. See, you can look at the data. It's not exactly the data we want, but if you perhaps unwrap it or change the level. Okay, now compare this data. Now this data is actually correct, so we can use it for our stuff. Yeah, so that's working. So a point, just a single point number and list repeater can give you the data that's similar to the data that's output from line. So again, that's kind of a way we can making sense of data. You know, if only the fewer text is kind of nice. It's kind of give you kind of the data in a list like this. If we cannot look at the data like a tabular in a tabular kind of table yet using Sverchok, but viewer tag is good for that. Okay, for this, where were we? It's kind of when if you're looking at if we switch to Blender cycles real quick, and then really if we have like plane, and I'm gonna create a material and gonna generate a texture. Let's see, gradient. This material, where's the material? Okay, this is the default cycles. We have surface, volume, and displacement. And I haven't played much with each one of them, but soon enough I'm gonna touch more on those. So if we have gradient, texture, and then we have color, and we render it out, and instead of diffuse I'm gonna turn it into emit, so it's like a full color. This is a gradient, right? Gradient, we know the gradient goes from black to white, and black to white, if we imagine it as a number, is a number going from 0 to 1. And if color ramp is kind of similar to that. Maybe with a gradient texture we have the vector color ramp. Maybe by default it doesn't know where to put the color, so we don't get anything. But color ramp is useful to kind of make things more contrasty. So yeah, so gradient texture, if we have like two white color here and one black, and we make them really close, so we have like a line. So that's kind of thing, like in my mind, after studying all about those shaders, generations, using functions, and then understand a little bit more about random and then noise. It's just all about numbers and how you can turn the numbers into something else that you need. Like even okay, with gradient you can have linear. Linear is simply like a value that goes from one value to another in a linear fashion. That's linear, and then you have quadratic, easy, diagonal, spherical. Spherical actually can create circle in this case, and then if we use proper texture mapping generated, or you don't have the UV, maybe the objects. Okay, we have the circle. We have circle from based on spherical. There's also radial. If we have two black color, perhaps we can have like a something that's more like a triangle. So radial, the functions behind radial itself is probably can be complex to recreate, but using node and then using these functions that's inside the node, suddenly it's kind of become really simple in a way. So that's a circle, and you can repeat this multiple times, and then you can perhaps create another black color and continue making it. So this is like based on the texture, and then you kind of creating these circles and circles, kind of like in when you're in a Sverchok. And let's stop the rendering, and we are generating circle like this. They are similar, but it's just not so easy to understand at first. Okay, like circles, yeah, circles is cool. We can also, in fact, we okay, let me randomize the rotations. We're not gonna touch the scale for now. The scale now is controlled by the smallest circle and the biggest circle because it's based on the cylinder, you know. Still remember? If we have random vector, and then how many do we have? 7 or 8, and plug it into rotation, and then with the angle, if we plug in a float, now we have this kind of setup, which can be quite complex. This you can create if you're using Blender and array modifier. You can generate something like this. Obviously, nothing too special. However, this is generative. You know, you can randomize it. You can actually animate this. If you find this hard to animate using Sverchok, you can use Animation Nodes. Yeah, and I like that idea, you know. If Sverchok is kind of hard, it's like this, but it's generating all the elements you need to animate using Animation Nodes. So that's like a win-win things. You're not gonna rotate it using Sverchok, and it's just gonna be messed out. MK2 limit viewer and edges and the matrix. Hide this. Now we have this guy, and with this guy, if you group it, actually you can group it here as well. I scrub it to update it. Now each of this output is grouped. switch to animation nodes, and you get objects, objects from group. Get that group objects, and we can look through objects, and then can use object transform output. It's slowing down because I'm recording and using this, so I'm just gonna use frame change. Here we can, for each and every object, we can randomize the rotation using wheel, Euler wiggle, my favorite. Euler wiggle itself is a noise functions at work. Randomize the seed, plug in the Euler. We have that. We can randomize it, and we can use frame number to plug it into the evolutions, and then we have like something that's look like a planetarium kind of rotations. And you go back to Sverchok, you can still increase the number. Maybe not in the subdivision. Okay. Oh yeah, okay. I forgot. We need to plug in the. Okay, let's stop this first. Subdivision 16 here, but the line we don't have 16 of them. Plug that in and plug that in. I plug into the wrong thing. Say 30. Now we are back in control, back in business. So that might be what you want. Still have control over the vertices. Even though sometimes maybe the rotations is a little bit messed up. Maybe it's a bug or something, but it doesn't always update properly. Then sometimes you have the leftover because maybe Sverchok doesn't quite update the instance. It's generating everything live, you know. So all is being generated live. Sometimes if we turn this back to 5, and okay, Sverchok didn't delete the old one, maybe, so it's got confused. But that's okay. Let's delete animation node, back to Sverchok, delete the bmesh, delete everything, start from nothing and back to where we were. So that's with that's actually we only using cylinder and UV connection, only 2 nodes, and it does a lot. You can have let's see, if you are using the V directions instead of U directions, we have line now, and line is also a different thing. We have the top and the bottom. Okay, cool. And this is line. This is 5 lines because the cylinder subdivision is we set to 5. Apparently changing the vertices now, controlling the number of lines. That's cool. We still have control over the top and the bottom, of course. We can actually connect this and we have almost like a flower kind of pattern. This is again the thing, if you're trying to create a functions that generates that kind of flower pattern, it can be complex, right? You need to understand a bit of math and just try to get this kind of design can be really complicated. But if you understand the node like cylinder and UV connections, what it does to data, you can have this pattern, and you can, of course, with this you can randomize the scale, perhaps, or if I use randomized input vertices, I think this guy can quickly add more variations like that. That's also can be really useful. Depends on what you're doing. For flower, it's not, maybe not so, yeah, that's a little bit too random. But if you're using it to plane, so instead of cylinder, if you plug in plane and separate the plane, and you can have more lines and then turn off cycles, so you get something like that. And obviously with plane it's different again. I think I'm plugging to the wrong thing. So we have the control over the step. We have control over vertices X. This guy must be going there. Okay, so that's also can be really useful, really useful. And that's just by randomizing the points using randomized input here. Okay, maybe we don't do that for now. These lines, let's see if we can randomize it using scale. Scale vector, try random. Always try using random first, and then if you can see the numbers changing using random, then you can use noise or using other functions or using your own number patterns, and you will see. It's a random vector plug into the scale, and we're getting some craziness. That's probably not what we want. However, it's interesting. Scale, plug in there. Maybe it's scaling the lines in the, and each one of them have different default, so they're not very happy. It's going up or down. Maybe we can break it down. So vector out and vector in. Let's try this. Just plug in just the X and the Y. Maybe just plug in the Y. The X is 0. The count can be the same as this. Looks like still the location is a bit random. What if I cut the locations? Not much of effects. The scaling is randomizing the position as well. that's okay. But as we get to the components, for example, we know that the X is controlling that. Maybe we can use random number, random. There's a random vector and there's random. Random is gonna generate just numbers. And if we plug this in there, we get that kind of design. And we can perhaps just remap it. And probably at some points I already show you how we can do this using just lines and the matrix. But in this case we are using this plane. We can control the stepping. just a different way, and we have a different result, even though it's a bit chaotic. Maybe because one of the data, like this matrix probably doing too much, you know. If we can maybe separate the matrix and then controlling each one of the lines from their own pivot, we get a more controllable result. Let's get back to the cylinder because I kind of like the circular kind of design. So back to cylinder, plug that in. Fit cylinder, we need the V, and now we have something like that. Why is it? Because of the scaling, I think. Let's reduce the number real quick. 10. Okay. 10 goes into subdivisions. We have control of the radius top and radius bottom. The vertex is controlling the number of lines. This probably confused. Random sometimes is scale. Maybe we can have let's try float range and plug this into the scale. It won't like it because this is a single value and scale is expecting 3 value. So we can use vector out or vector in. Plug that in. Plug in there. Okay, now we have control over the scale. I think turn on the count. Start. Let's start from 1 and stop at 10. So you can see there's interesting things happening here. Looks like with the scale, apparently when we are separating the cylinder and breaking it down into components like a line. It's unlike the circles, where with the circles we say when we break it we get like 12, and with 12 circles each one of them is kind of separate, but with this guy all the lines, we're not getting what we have with the circles. So that's why when we are scaling it, I'm not getting kind of what I'm expecting. It's kind of weird, like we have two different objects. We have this matrix 10 as well, which is a little bit strange. We might be able to separate it using a list flip. Maybe not list flip, but list repeater or list separate. List split. This list split probably what we want. How many do we have? 10. 10 and 10. Unwrap, unwrap. I'm kind of trying to get the number 10 right here. Oh well, I think that didn't quite work. But yeah, so I think today we kind of talk about points and then line, and then we have grid as well, grid which is made of lines, and we also have cylinder which is made of circles and lines. So with Sverchok sometimes it's probably unlike any other node-based system that I know. With Sverchok you can separate data into different lists and then kind of tweak it, and then because there are so many list functions here, they're kind of like a recipe to there can be recipe for chaos or recipe that you can control to get what you want. So yeah, that's actually pretty much my main points here. Maybe I should show you one more thing, or should I not? Maybe I'm just gonna draw it. If you have like a cone and you slice it, in a Sverchok you have cross section. This is probably what I should show you. Also, a cone is a 3D object, right? But if you slice it using plane, what you're gonna get is circle, like a bunch of circle, or maybe more like ellipse. And that's also interesting in a way. That's kind of like if you have a functions that making objects look like wave, whether it's like a displace modifier or you're really using math functions to generate this kind of wavy objects in 3D. If we kind of slicing it in a certain axis, you're gonna get something that's more like a gradient in a way. So that's what I'm getting when I was learning about shader programming. So shader programming, like I said, is using a lot of functions, and sometimes with those functions, and you're using you're basically typing like functions. You define a function that generates maybe it's gonna generate like a gradient or those sort of stuff, um, and you can probably loop the functions just to get what you want, you know. In such a way, you also already have it here in a Blender cycle, for example, like in with this guy, like the wave texture is probably made up of certain functions, noise as well. All these functions you can mix and match together. That's basically my main point. If you understand the underlying functions that's generating a texture, you can then resample the texture or combine the textures, multiply it, subdivide it, um, to get what you need. Sometimes you think, hey, that looks really complex, but if you know, if you break down the complexity, probably what's underneath is not that complex. Otherwise, if it's really complex, if you if you cannot control the complexity, you can't possibly recreate that. So basically, in the whether it's a line or a circle, like this is like really complex. Somewhere in between, you know, somewhere in between like a super controlled stuff, you have this is something that looks looking natural and beautiful, just like the nature. So that's basically the main point of this live noding video. Yeah, sometimes with Sverchok, I still don't quite get the data, but I think I'm getting better with that, and I have probably to watch some of the Sverchok developers video as well, and then just to get really understand it. And at the same time, I want to understand more about shader programming, and then maybe Python programming as well. So yeah, hopefully that's this video has been useful for you. So this is another live noding video with BlenderSushi. Hopefully, if you can leave comments and you can like the video and then subscribe to it, and I will continue to make more video like this. Probably not always talking about the like complex stuff. Not for a lecture like that is it's hard if I just like improvise. Yeah, so I'll see you on the next video. Thanks again for tuning in.